Let's go over those problems from activity number 1, but only about section 1.1. So first problem, what we can do is we can move all the terms to one side and use sign chart method, or if you realize this is actually a linear expression, so I could have minus 3 to both sides of the expression. So it's minus 3x greater than or equal to negative 2. Be very careful, you're going to divide by negative 1/3 here. Divided by a negative number means you are supposed to flip the direction of the inequality, and therefore your final answer would be less than or equal to 2/3. If I were to express it in the interval expression, it's 2/3 and it's closed bracket on the right side. For the next problem, if we were to go with sign chart method, my first point is -1. My second point is supposed to be 2. So putting them on the number line, it's -1, it's 2. So my testing points could have been selected as -2, 0, and 3. It's my preferred idea to get 2 vertical lines there. So it's easier to discuss the sign. What we have here is positive, positive, and negative. So if we were to multiply them together, this is what we end up with. So my final answer, I'm supposed to pick the first and the last interval, which is going to be -infinity through -1, combined with 2 through +infinity, because the original problem is less than or equal to, so I know that I should be using bracket to include both endpoints. The next problem we have is not having 0 on one side, and it's not factored, so I need to make sure I put it into the proper structure before I start doing the calculation. So it's x squared minus 3x minus 4 greater than 0, so it's x minus 4 and then x plus 1 greater than 0. So I end up with two special points, 1 and -1 and 4. Putting them on the number line in the correct order. The rest part is relatively straightforward. You choose your testing points and then you put down the sign of each part. To put them together, your final conclusion is like that. Add the boundaries to make it easier and to visualize. So my final answer is -infinity through -1 and 4 through infinity, and I should use bracket. So the next problem I have here is x minus 2 divided by x plus 3. So by setting both numerator and denominator to be 0, what I end up with is x equals 2 and x equals -3. Similar idea, put both of them on the number line and you test the sign of each part. So what you end up with is a sign chart like that. So you can do the testing of sign pretty quickly. So you end up with negative, positive, positive. So the final output is going to be like that. And don't forget, your problem actually had strictly greater than, so your final answer is to pick the positive pieces, -infinity through -3 and 2 through infinity, combine them together. So that's what you have as the final answer. The last problem we have here is a structure which does not have 0 on one side and it's not factored. So what we have to do is to move all the terms to one side and then try to work it out in the way that it can look like a lot of multiplication and division putting together. So I end up with x squared plus 4x plus x, which is 5x plus 4, and then plus 2. They share the same denominator, and then it's x squared plus 5x plus 6 over x plus 1. Hence it's x plus 3 and x plus 2 divided by x plus 1 greater than or equal to 0. It's relatively obvious for you to realize those are the special points, but don't forget -1x actually makes your denominator to be 0, which could be problematic. So when you move things to your sign chart, you are going to test the sign one piece at a time, and then by doing the quick testing, choose your points wisely: -3.5, -2.5, -1.5, and 0. So you realize the sign of each pieces were negative, positive, 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 negative, negative, positive, positive, negative, 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 positive. So what you're looking for are the pieces where it's supposed to be positive, but also it has equality here as well. So you want to include the boundary points. So it's negative 3 through negative 2, and negative 1 through infinity where they are positive. I want to include the boundary points, but I cannot include the point of negative 1 because it makes my denominator to be 0, so I threw that one point away in particular, and that's my final answer.